Hi everybody, today let's learn about how to find the arc length of a circle. You learned this before, so remember arc length is equal to 2 pi r times theta over 360. 2 pi r is the circumference of a circle, but if we are just looking for the arc length, it means just part of it, part of the full turn. That's why we have to times theta over 360. The theta must be in degree if you use this formula. So today we are going to learn another formula that we can use to find the arc length also. Okay, before I show you the formula, let me go back to this one first. When the arc length is equal to r, when the arc length is equal to r, what is the theta here? The theta is equal to 1 radian, right? When the arc length is equal to 2 times of the radius, the theta is equal to, let me write again this. The theta will be equal to 2 radian. When the arc length is equal to 3 times of radius, the theta is 3 radian. Okay, so the theta in radians is actually the ratio of the arc length, the ratio of the arc length to the radius. Okay, you see this one. When s is equal to r, when the arc length is equal to r, you take r divided by r, you get 1. That's why the angle is 1 radian. When the arc length is equal to 2 times of radius, you take 2r divided by r, you get 2. That's why the angle is 2 radian. When the arc length is equal to 3 times of the radius, you take 3r divided by r, you get 3. That's why the angle is 3 radians, right? So theta in radians, okay, let me write this. Theta in radians is equal to the arc length divided by the radius. So when both sides I times r, what will happen? I will get this times r for both sides. So here I will get r theta, here I will get s. From here we get the formula that we are going to learn today. S is equal to r theta. So this is another formula that we can use to find the arc length. If you use this formula, make sure the theta here is in radian. Okay, now let's try a few examples. Here are the two formulae that you can use to find the arc length. This you have learned before. 2 pi r times theta over 360. This in degree. The theta is in degree. So today, this is a new formula that we want to use later to help us to find the arc length. S equal to r theta. The theta must be in radians. Okay, now let's look at this one. So in this questions, the angle is given in degree. So we can use the formula that you learned before. So how about we try both? Then we compare the answers. So arc length. Okay, I just write S. The S is equal to 2 pi r. The r is 8.5. 2 pi r, but 2 pi r is the circumference of a full circle. Now we are not looking for the full circle, we just want part of it, which is 100 degree out of 360 degree. That's why we have the time 100 over 360. Since the questions doesn't give us the value of pi, so we just use the pi from the calculator. So 2 pi r is 8.5 times 100 over 360. Okay, so I just convert to decimal and round off to 4 significant figures. It will be 14.84 centimeters. Okay, now how about we try to use another formula, see whether we get the same answer or not. So S is equal to r theta. So since you just learned about this, I will suggest you to write this formula for a few times so that you can remember it well. Remember, if you use this formula, this theta must be in radian, but this angle is given in degree. What we need to do is to convert this angle from degree to radian. Okay, I hope that you remember how to do the conversions. Pi radians is equal to 180 degree, right? So from radians to degree, the radian from radian to degree, number become bigger. We have to times 180 over pi, right? Okay, so from degree, I think I write this way. Radian degree. Okay, so radian to degree, number become bigger. We have to times 180 over pi. Degree to radian, number become smaller. We times pi over 180. Okay, now this is degree. We want to convert it to radian. Number become smaller. We take 100 times pi over 180. Then it will be converted to radians. Okay, let's press our calculator. $1.7453. Okay. So now I'm going to apply this formula and see whether we get the same answer or not. S equal to R, which is 8.5, theta, which is this one, 1.7453. Yes, we get the same answer as well, 14.84 centimeters. Okay, so this is the formula that you learned before, and this is the formula that we are going to learn today. Okay, now let's try another question, part B. Okay, so here I will just show you one method which I will use this S equal to R theta formula. So if you want to use this S equal to 2 pi R times theta over 360, later on you can try use this formula and compare the answers. You will get the same answers. Okay, if I use this one, okay, let me write again here so that you won't forget. This is degree. If you want to use this formula, this will be in radian. Okay, now first I want to convert this degree to radian. Number becomes smaller number on the top. $295 times pi over 180. 5.148. Actually, if you take four significant figures is already enough, but since I want it to be more accurate, I take 4 decimal places. 5.1487 radian. Okay, now I have the angle in radians, so I can just plug in this formula and find the arc length. S is equal to R theta. R is equal to 10. Theta is equal to this. Okay, so you can just round off your answer to 4 significant figures. If you don't want, you can give your answer in this 51.487 centimeters. Okay, now let's try another question. The diagram shows a circle with the center O. Okay, this is the center of the circle. Oh, let me use red color. Okay. Given that the length of the major arc, okay, you have to be careful here. Major arc, PQ. So what the question is trying to tell you is the length of the major arc PQ is 34.89. It's not over here. It's not here. This is minor arc. Major arc is actually over here. Okay, this is major arc, 34.89 centimeters. Okay, and the angle POQ is 0.7 radians. Find the radius of a circle. So I think first thing come to your mind is this formula, S equal to R theta, and this is S. We don't want the R, we want to find R. But how about the theta? We cannot use this angle, because if you use this angle, the arc length that you get is actually here, minor arc, it's not here. So let's say if you want to find the arc length over here, you need to use this angle. Okay, so how do we find this angle? Still remember, 2 pi radian is equal to 360 degrees. So it means that a full turn is 2 pi radian. If I want to find this angle, I just take 2 pi minus 0.7. Then I will get this angle. 2 pi minus 0.7. 5.583. 583. Okay, I take one more decimal places. 5.532. Okay. So it means that this angle is 5.5832 radians. Okay, now I have the radians, I have the angle here, and the arc length. So I can plug in here and here to find the radius. S is equal to this, given by the questions, right? 34.89. S is equal to R. We don't know the R. We want to find the R. Theta is this. Don't use this one. Okay, use this one. Since that because the arc length is over here, so we have to use this theta. If the arc length is here, we use this theta. Okay, 5.5832. So R is equal to 34.89 divided by 5.5832. Okay, later on you might get very long. You will get very long decimal. It's okay. You just round off it to 4 significant figures. Okay, so the answer is 6.249 centimeters. Okay, so this is the way how we solve it using the same formula, but sometimes the question asks us to find S, sometimes the question asks us to find R, sometimes the question asks us to find theta. But we are all using the same formula. Okay, let's try next questions. So here, how about I just show it this one. This one you can try your own. I think it should be no problem. Theta. Okay, now we want to find this theta in radians. So still remember just now what the formula? S is equal to R theta, right? Okay, so we want to find this. First, we need to get this angle. This angle. So now I'm using this formula. S, which is equal to 16.4, is equal to R. Theta. Okay, so how about I just let this be theta, theta 2. Okay, so the theta 2 is equal to 16.4. Okay, let me write again this one. 16.4 divided by 8. 16.4 divided by 8. Okay, you will get 2.05 radians. But this is not the final answer yet, because we are looking for this theta, right? So theta is equal to, full turn is 2 pi. So we take 2 pi minus this angle, which is 2.05. 2.05 radian. Okay, let's see. 2 pi minus 2.05. Okay, so the angle is 4.233 radians. Okay, now let's try one more question. Okay, this time let's try this one. So this might be a little bit harder compared to the few previous questions that I discussed with you. Okay, let's see how to solve these questions. In the diagram, BC is the arc of a circle of radius OB. Okay, this is the center. This is the center of the circle, and this is the arc length BC. OB. O to B, this is 14 centimeters, which is the radius of this sector. OBC. Okay, ABD. ABD is a quadrant. Quadrant, it means 90 degrees of a circle with the center A. So this is the center for this sector. ABD. And A is the midpoint of OB. So it means that this is 7, this is 7, because the radius is 14 centimeters given by the questions. Okay, now we want to find the theta in radian. So that's how do we find this? Now we just focus on this triangle first. Ignore about the rest. We just focus on this. So we have a right angle triangle, and you have two sides over here. If you want to find the theta, we can actually use what? We use tangent. So you remember? Tangent. Okay, this is part A. Tangent angle CO. Okay, how about I write DOA or tangent theta? Easier. So since we have the symbol here, I just use this symbol. Tangent theta is equal to DOCA. So you remember DOA. Opposite divided by adjacent. So I want to find the theta, and the tangent 7 over 7 is actually 1. Okay, so now you can press your calculator. So shift, remember you want to find the angle, right? You have to press shift first, then tangents, then 1. Okay, then equal. So this angle is in degree. So if let's say you want to convert to radians, what you need to do is just time pi over 180. Okay, 0.7854. Radian. Okay, the questions asked for radians. Okay, so this is the answer for the first part. Now let's proceed to the second part, the parameters of the shaded regions. So it means that we have to find this one, which is arc length for this quadrant, and then BC, and the arc length, and plus this one. Okay. Parameters. This is part B. Parameters of the shaded region. Okay, let me do one by one. BD, arc length, R theta. Okay, so the R is 7, theta is 90 degree. 90 degree is pi over 2 radian. R theta. Okay, pi over 2 radian is actually equal to 90 degree. R theta plus another R theta, but this time the radius is not 7 but 14. Okay, this one we look at this sector, so the radius is 7. Now when we go to BC, the arc length BC, we need to use this radius, which is 14. R theta is this one, 0.7854. Okay, we left one more, which is over here. From here to here is 14, but we only want this part. So how do we get this part? If I want to get this part, first thing is to get the length here first, correct? Then I take 14 minus this one. So first I want to get this. Pythagoras theorem. So I am going to find the hypotenuse, the length of the hypotenuse of this right angle triangle. OD. is equal to 7 square plus 7 square square root. Okay. Square root of 98, right? So now I'm going to plug in this over here. This is square root 98. But I cannot plus square root 98 because I want here, not this one. 14 minus square root 98. Okay, now just press your calculator. Okay, so the final answer is 26.09 centimeter, right? Centimeter. Okay, correct. So this is the way how we solve these type of questions about how to find the arc length and the perimeters. Okay, that's all for this video. Hopefully you understand better after watching this video. Thanks for watching. See you next time. Bye bye.